Hello class. This is very short video to explain exercise 2 and individual assignment 1 and 2. I'm going through the RStudio first and then I'm going to review the Excel. Then I will back to show a few points on the individual assignment 1. Okay, hopefully you already downloaded the codes for the exercise 2. From the class you can go to the content and then click on week 2, go to the working toward bonus point, and this is the code. You can right click the code and save target as, and the code will be saved in your computer. Make sure to copy the code in UMUC folder, drive C. This is two types of code. The first one is with dplyr package. For some reason, if any of you was not able to we're not able to just install the dplyr package, you can work with no dplyr package. Okay, I assume that you already have the codes and just like to run the analysis. Click on the file, go to open file. I copy in different place, but I assume that you copy in drive C UMUC of computer. I copy in some other place. I'm gonna go and open it. Okay, this is I'm copying the Dropbox because I would like to have access all the time from different computer. This is week 2 exercise. Okay, here this is entire codes. This codes is for dplyr package. It's for Windows by default, developed for the Windows, but you with a minor modification you can use it for Mac. First thing first, if you already finished exercise 1, so you don't need to change anything here in exercise 2, just run the codes. If you are not able to work with exercise 1 and this is your first attempt for exercise 2, then need to install the package. Unmute the package. The code is muted. Unmute the installed package, highlight and run. I'm not running that because I already installed. Okay, and then this is make sure see UMUC for the Windows user, and this is sync command. This is data set. The data set is still the same data you use for the exercise 1, and then select everything. Which select all, you just press Ctrl A and click on run. As long as you see the blue line here, no error term, you can see all the results, and you can find the results in drive C UMUC. Drive C UMUC. Okay, the codes is week 2 exercise today 8/28 10:59 a.m. and this is all you need. The first one is for means, one for non-teaching, for teaching, 0 for non-teaching, and this is for standard deviation. And as see, there is a message here with one more variable. Okay, to fix this, let me close this. To fix this, you need to give more space to the console. To do that, click on here, drag it on the right, and then run the codes again. So for sure you will have this again here. I'm opening this and everything is fine, so you will see everything is here. These are means, these are the standard deviation, and these are number of observation. So It's rounded, no worries, you can report all the rounded numbers for the mean standard deviation. The only thing you cannot report a rounded number is for p-value, and this is the p-value. Okay, let me give you some reason my computer don't show anything here, so I like to give C on all of them here. Okay, here. This is the p-value, the two sample t-test, and this p-value compare the hospital beds between teaching and non-teaching, and the value is 2.2 on power of minus 16. This number is very small number like this. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 2 20. This is the real number. So if you want to report 4 decimal, this number should be 0. So it does mean there is a significant differences between teaching and non-teaching hospital in viewpoint of the number of hospital beds. See, for the teaching hospital, the number of beds is 549. For non-teaching is 299.6 or 300. We have the same number here, 300. We have for, okay, that's the other numbers. Okay, let's mix in one more. The other things is significant here. It's not significant here for non-paid. See this 0.14. 0.14 is more than 0.05. It's more than 0.14 is more than 0.05, so there is no significant differences. If you look at the mean is close to each other, 57, 27, but if you look at the standard deviation, it should be very high. Standard deviation, look at this. Non-payer, okay, standard deviation is really high, 32. So 102, it does mean it's really high standard deviation, so that's the reason you cannot see. Okay, you can look at the entire text file to see the other codes. Do not save it. But if you like to see the results in the console, so now I copied all the results on the sync on the log file. If you like to see in the console here, you need to mute the codes, mute the sync comment, and then run everything here. If you run everything here, you will see all the results in the console. This is helpful especially when you want to look at the number of observation. This is here, look at the point teaching hospital. This is the number of hospital beds, 936, non-payer, worker. So I'm giving you a few examples to make sure you are in the right direction. And this is for non-teaching hospital, is 2094, and that's it. Okay, the assignment also asks you to what are main, okay, the assignment is compare the following information. Okay, the information, okay, report this. What's the main significance? To look at the p-value and make a decision about that. If it's less than 0.05, there is a significant differences, otherwise it's not significant. Compare hospital net benefit. I already computed in the code, already computed the net benefit. You just need to look at the p-value here and see is it significant or not. Use the box plot. Okay, this is the box plot here. If you look at this, make sure this is in the, because this is file, this is plot. Make sure your computer is on the plot, and you can go back with this key and see the all the results. Though this is a 3. Okay, we have figure 3 comparing total hospital cost between teaching and non-teaching. The house, as you see here in the box plot, this line, this bold line, explain the mean, and this bold line, these are standard deviation. To a standard deviation, to a standard deviation here, and this is these are kind of outliers. So for this assignment, we are not going to remove the outliers, but it does mean in the teaching hospital you're more likely to have more outliers. and for sure the teaching hospital has a teaching hospital has more likely to have uh, more cost than non-teaching hospital. Okay, you can go back. Okay, comparing net revenue between teaching and not teaching. So as see, also even here, net revenue in the teaching hospital is higher than non-teaching hospital. Um, I have total hospital between comparing total cost. I believe here I remove the outliers. If you look at the codes, yeah, yes, I remove the outliers here. We see when we are removing the outlier, you can see this picture is much clearer than the previous one. You can easily see the teaching hospital has a higher cost. Also, you can look at the same for the revenue. So even if I just remove the outlier, you can see these things here. Okay, this is RStudio. Make sure to just save your code. If you do not save that, and then I'm gonna remove the sync from here, because by default I like to keep everything on the text file. This is the file. So some of you maybe like to work with Excel. So this is the data set you already have. Let me explain. This is the data set. If you look at the data set has 30,030 observation, right? See here, this is all the observation. As I explained the first exercise, you don't need to see all of them. You can hide from line 2 until line 3039 29. So you have, so then you can see what you are doing. Otherwise it's very difficult to do that. Let me hide this one, so I can see the first and I can see the line. This is line number 2, line number 3031. So you need only these two. You don't need to see the entire file. And let me hide this one. I'm gonna go with exercise 2 only. This is exercise 2. You can copy the question from the class or from any other. You type it anyhow, it's up to you. And then we have a teaching, we have non-teaching. First of all, we need to find the teaching variable. This column H, report the teaching status. 1 is for teaching, 0 is for non-teaching. So you can use counts if this is, let me give you higher. This is the code. Hopefully I can copy here. Can I copy the code here? No, the code is the function is copying. So this is the code. This is the code. It's counts if open bracket H from line 2 till line 3031. If this does mean if 1 if teaching, and then report number of observation for hospital beds if more than 0. So by using these codes you can see the number of observation for teaching hospital. For the means, you can work with average ifs. So then you can say the average is first of all filtered by teaching. The teaching variable is h, right? So you can say if teaching variable is equal to 1, then compute the average for F2. F2 is a hospital beds from F2 till F3031. So you can enter it and get a result. For here, a standard deviation, you can use the standard deviation command, then filter by teaching hospital from H2 to H3031, and then compute a standard deviation for hospital beds. The point here is you need to press Ctrl Shift by Enter. Ctrl plus shift plus enter, so you can see the standard deviation. Then you can copy the code from here to this. So for here, so first of all the variables was h, right? So then, but still you are still the f, you need to keep it as a f, hospital beds 939, and then this is 0, right? Because we are going to see non-teaching. Okay, this is non-teaching, you can change it to 0, but this is still f. When you are copying something in Excel, by default Excel change it automatically to the different row, so you can fix that. And then a standard deviation, h2 is hospital teaching, again here 0, but this is f, and you need to press Ctrl Shift by enter. Okay. The interesting points about the standard deviation, about the computing p-value, RStudio use a standard error to compute the t-value. To do that, you can look at this. Let me open this formula for you. This is the formula you need to compute the t-value. This is the mean for first population, this is the mean for second population, this is a standard error for the first population, this is the n for first population plus a standard error for the second population divided by number of observation, n for second population. So first of all, we need to compute the standard error. Whenever you have a standard deviation, let me hide these lines so you can see it easier. We have a standard deviation, right? To compute the standard error, you need to divide a standard deviation divide to a square root of number of observation. Number of observation is 936, and we have a standard deviation 445. We need to compute, we need to divide it 445 to a square root of 936. This is, you can do it by this command, or you can do it manually. For example, if you want to do it manually, first of all you need to compute sqrt of this variable, right, 906, and then you need to divide this to this. This is the same number, right? So you can do it all of them together as one. The easiest way to do that, you can just copy exactly the same option with going components, so equal this, and then this equal this divided by square root of this. The same for this part. You can, whenever you finish with this, you can copy it here. So here you don't need to change anything. And this is the same number here. For the t value, you need to go with this formula, the formula I showed a few moments ago. A first means minus second mean divided by a square root of a standard error of 1 power of 2 divided by n, 936, plus a standard error second one, 9.7, divided by number of observation, 2094. And you will see this t value whenever the point is, whenever you have a really high t value, for sure this is a significant. So to do that, you can go with this formula, TDIST, absolute value of t, and number of population, number of observation. You can go with the higher number. The highest number here is 2094, right? But this is also two-tailed t-test. You can press enter and see this is a 0, so I put the same 0 here. This is a 0. You can copy you can compute on the other part by following this approach. Okay, and the other things you need to go ahead is that just to compute, if you like to report the graph for the Excel user, you can report a box plot, or you can just report line, I mean bar chart. You can go to the insert and then use this one, right? You can click here and see the bar chart 1, and then you can define the label 1 and 2. Teaching, 2 is non-teaching, or you can go with this. I know for here you need to compute the cost and revenue. You just need to report the benefit, cost and revenue, but I didn't compute that. You need to compute them and then either copy here to report the to compute to insert the graph, or you can go with a box plot. This is some place here. This is a box plot. You can go with a box plot, computing 2 of them. Okay, this is for exercise 2. The last thing is for individual assignments. I already explained in the live session, but this is a template for the individual assignment 1 and 2. So now we are going to use this template for individual assignment 1. You are free to change this based on your writing, but keep this section as it is. For example, you should go with introduction, method, hypothesis, data, material and method, variable, method, data analysis process, and results, and discussion, limitation and conclusion, and finally recommendation plus references. I expected you to have at least 2 references. I'm going to give you an example. The master codes is available in RStudio. I will go through the RStudio first, then I will give you an example on Excel. For example, here I'm trying to compare diabetics between black and white population, right? And this is the codes. In the class, I put all the data you need for this assignment in discussion. You go to the discussion, go to the class instruction, and depends on your topic, you need one of these data sets. For example, if you choose the topic for Medicare beneficiary, any type of topic related to the Medicare beneficiaries is the Medicare National Data by County. Any topic related to CT, MRI, an imaging service bag, you need to go with an imaging data set. Any topic related to the hospital admission, length of stay, something like that, back to the Minnesota data. And these are example of codes, and this is a template. Here let me close this because I like to give you example on iExam. I changed it last night during a live session. Okay, here this is what I have. This is the codes I posted in the class. No, this is not. This is it. iExam code. Yeah. Okay, first thing first, you need to read the codes, right? Read the data sets. You copy the codes. This is the read the data sets. Read the data sets. Okay, the data is reading. Let me a little bit minimize it. You can see entire page. Okay. Okay. Okay, this is better. Okay, reading the dataset and then look at the variables. Click names, dataset, give you an entire variable in this dataset. Then you need to use mean function, standard deviation function, my table function. The mean function give you mean. If I run here, you can see the mean for the I exam, standard deviation for I exam, number of observation for white, black and white. This is a 1259 for black, 2100 for white, and then I'm like to compare them. The t-test is less than 0.05. There is a significant differences between two. It does mean a white population here, white, right? 66 more likely to have higher high exam. Then you can look at the box plot. This is box plot. You can click on this, copy to the clipboard and copy plot and paste in your Word document. And here, if you'd like to go to the density plot, you can run these codes and you can see the density plot. This is a black and this is a white, and you see most of the time white population, except for the less than 40 percentage, the black is a little bit higher, but after 40 percentage, maybe after 35, white more likely to have higher eye exam. And you can copy this to the class. So what do you need if your topic are different than eye exam? For example, you are working like going to run an analysis to check percent of diabetics between white and black. So the things you need to do is you just need to change the name of variables here. So here the percent of eye exam black, you can change it to percent of diabetics black. You can copy the codes from here, paste all the place that this is a black, paste here, black, paste here, and then white, percentage diabetics for white, white here, white, 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 and white. You also need to change the title here, right? Comparing Medicare diabetics, right? Actually, you can paste here, but percent of diabetes. You can fix this 13% of diabetes. Okay. You can also fix here percent of diabetics. Also need to fix here. So the code is ready to run for diabetics. So if I run this, you can see different plot here. So you can click on back, see the box plots. Going forward, see the density plots. In the first part, most of them doesn't have, so you can see almost 3% of population. And then this is for the rest of. And then you can see all the information here. So this is an example for the extra individual assignments. So if you decided if your topic is comparing two states, you need to use the subset data and for each state. For example, I can give you an example on the number of beneficiaries in California and Florida. The data set is still the same data sets. You can use a command like table, name of data, $sign, and state. If you run this code, you can see all the states here in this data sets. This is the command table, open bracket, data, states. The data is this one. I'm looking for Florida and California. Then you can use the subset command, California subset data, state is California and Florida, and then you can use the same mean value. Mean, you make sure your data set for California is CA, for Florida is FA. This is the variable. This part is the same as previous example. This is mean command, standard deviation command, and this is, I repeated here. So, and this is my table command. You can see the numbers, and then the t-test, you can just go at California with Florida, and then the plot is gonna be California, Florida. It should be beneficiary, right? Beneficiary, and you also need to change here beneficiary. Make sure change it to the beneficiary, right? Anything between this two quotation mark is a writing. You can put everything here. Make sure to fix this also. This is a percent of number of beneficiaries. You can do it manually. Number of beneficiaries, so we can make sure you complete this. Okay, and then the same here, California, Florida, and make sure to change this one, and this is it, and then that's it. You can run the code and everything will be okay. This is an example. Most of you are using Medicare national data, or if you're working in Minnesota data, the pattern is almost the same pattern. You can use that. This is very easy to go. But if you decided to work with Excel, right? Some of you may like to work with Excel. This is the data. This is the data, right? You can use the same. You can use, if you copy the data in Drive C of your computer, you can open it from that, and you assume you want to go ahead with percent of black and white population in entire state. So we have lots of variables here. 3000. So this is 3000. You can see that this is 3000. Again, you don't need to keep all the code, all the data here. You can just stay with first line and the last line, and hide this one, and then make sure this is okay, this is here, stay here, the last part of your data is here. So if you want to go with a mean, you can use the count, right? Count for number of observation. I'm talking about the entire observation, not between any other population. If you'd like to go with a black and white population, then you need to filter that. You can go with the mean command to just the average command to compute the average number of beneficiaries. You can go with the standard deviation command to see the standard deviation command. If you have decided to work with different states, then you can use the same command in the exercise. You can use the count if count if and find the column for the state and filter that. For example, let's see, let's copy this code here, and okay, this is the code. Okay, let's do it one more time. Come on. Okay, you can copy. Let's go and call something. I just copied this code. Let me back it here. Okay, I'm copying this code, right? I'm pasting this code here. Oh, not some. I put equal. Let me go back here. I like to copy this code only. I don't need anything else. Um, let's see what's happening here. Okay, I'm copying this code here, and I like to see only, for example, percentage of number of beneficiary. Let's say number of beneficiary, the first column, column D, in Alabama. The Alabama state is derived C, is column C, right? I can say C2 to C3000, C2 to C 3143, and it should be Alabama only. And then I like to see compute the number of beneficiary 3043. I like to see if it's more than 0. So this is so what's happened here. 3000. Okay, let me remove this also. Okay, let's see. It should be D2 till this one. State C D 2 to do D 143. Okay, that's a 63 of them are in the Alabama. If you like to go with, for example, any other state, for example, the California, you just need to change it to the California 58. And for example, go with Florida. You can do the same to see the count. You can use the average if I used already here for the exercise, and to compute the average. Let's go here. Make sure you don't use that as I'm just doing here. So let's say I like to compute the average. This is the count, right? This is the n. It's actually the mean. Okay, I like to see the mean for only for. Let's I copy this code here. This is a count for only Florida. I like to see the average for Florida, then I need to go with average if comment Florida, and I need to remove this one for the average. Okay, I need to also change this. For the average, you need to put it in the second part. This gives you the average, and for the standard deviation, you need to go with the same command I already used here. This is the standard deviation. I'd copy this command stdev, and let's paste here. And you like to see the California, and you see the only Florida, right? This is the Florida. This is the D2, the T3000, 143, and I like to see, oh, this is the C, right? This is the C, and I like to see the D, right? This is a D2 till D 3143, and you need to press shift and enter. Something happened here. What happened here? C. Okay, and I should press. Why is it not working here? Maybe it should be more than 0. It's not. Let me see what I did here. I should work. Why is it not working? Standard deviation C. State is Florida, and D 3000. That's it. It should work. Okay, maybe the Florida doesn't have too much different. Let's see. Let me change the state to California and see what's happening here. Okay, now so this is a problem with code. We have to fix this. Florida C2 and then D2. That's interesting. This is one of the reasons I do not suggest using the Excel, because it's taken so long time to work on this. Okay, it should be D2, 3, and C2 should be this one. Okay, it doesn't work. 3142, because the last one is entire the US, and let's do it here. Doesn't work. Okay, what is the message here? Help on this error. How to calculate a value. Okay, I don't like to go with the help. This is a long way to go. Let's look at this, what I did here. This is the first standard deviation, STDEV. Did I go with that? Okay. STDEV. And then what I did here. Oh, first I filter that and then go with a second. I can switch that to see if is it working here. First I can filter this, and then I can go with the second part. Hopefully it worked. Doesn't work. Let me see what's wrong with this data. If I filter the data only, hide this. Oh no, don't hide this. Unhide this, and then filter the data only for Florida. And you can see the Florida here. Okay, number of beneficiaries here. If I want to see a standard deviation, should see this one. Okay, this is the alternative way to go with this. And then you can just unfilter the data, but should be fixed here. See here, and the D here is D32, so I have to be able to see this. Okay, let's see. see standard deviation filter Florida. The Florida, how they spell the Florida. Let's see. FL. This is my last try. Come on. FF. Oh, FL here. No, that's correct. Okay, here stdev. Let's see if I go with entire, what's gonna see that. What's gonna be the result? D. Okay, I can see the result for D, and then I can like to see the result only for Florida. I can go and filter the Florida. What happens if I go here, change this with this, and then press this one? Okay, it doesn't work. Okay, interesting. Okay, go with the filter command then. It's much easier to go with the filter command, filter this, and work with the standard deviation. And I will see this one. If I go with the filter, I will try to find this later, but there is problems with this. But for now, I'm gonna close this. I like to select only Florida. Oh yeah, okay, that's it. And then you can compute this number. Here is the standard deviation. Okay, this is the number 32486. 32486. Let's back 32486. Let me try one last time. Standard deviation C, Florida. What happens if I remove this? Control Shift doesn't work. Okay. Oh, it doesn't work. So go with the filter command here. So I will try to find this and back to. Okay, class. It was an example for the exercise 1 and the visual assignment 1. I'm going to close this live session and not this command in this video. Let me try one last time. What can I do with this? Why it's not working? By default it should work. Okay, let's see here. What happens if I put here, change this to a standard deviation and press this one? Doesn't work. Anyhow, never mind. I have to stop here, so and then compute the standard deviation using the filter command. Okay, thank you class. This is the end of this video. There is a detail oriented video for the R for the exercise 2. You can find it on the zare.rstudio on the YouTube. I think the link also is in the class. Thank you. Goodbye.